Section 4.5, converting base 10 to other bases. In this section, we're going to talk about how to start with the base 10 number and then convert it into a different base number. And the bases that we will be converting into will be anywhere between base 2 and base 16. So that's what we're responsible for in this class, is everything between base 2 and base 16. In the last section, we talked about starting with a different base and going into base 10. And then in this section, we're reversing that process. We're starting with the base 10 number and we're converting it into a different base. We'll go kind of quickly through a couple examples here, and then we'll switch to going through examples on the paper that we'll work through live. But say we wanted to convert the number 405 into base 8. The first thing we would do is start looking at powers of 8. See 8 to the 0 power, 8 to the first power, 8 to the second, 8 to the third. You notice that 8 to the third is bigger than 405, so 8 to the third power is 512, but 405 is not that big. So we're not going to need the 8 to the third power's position. We're going to need the 8 to the second power's position. Okay, so first thing we want to do is we want to know how many times 64 fits into 405. So we're going to do a long division. We're going to divide 405 by 64. So again, I'm going to go through this real quick, and we'll slow down when we hit the examples on paper. Go through the long division. How many times does 64 go into 405? You will find out that it goes in 6 times with a remainder of 21. So then what we do is we take that remainder of 21 and we divide by the next power of 8, the next smaller power of 8, which happens to be 8. So we're going to take that 21 and divide it by 8. We find out that it goes in twice with a remainder of 5. That final remainder of 5 tells me how many ones that we have. And so the 6, the 2, and the 5 make up our answer right here. Okay. Again, I know that was really fast and it's hard. We're not seeing the actual math, so I think it's going to be better in a minute when we look at our examples on paper. This is a reminder that when we do switch from one base to another, or basically from base 10 to a different base, when we're using these different bases, there's only certain digits we're allowed to use. So this showed up, this table showed up in the previous section, but I wanted to show it to you guys again. Say, for example, we're converting a number into a base 7 number. Our answer should only have digits like this in our answer. You can only have digits from like 0 through 6, for example, if you were talking about base 7. So this is pretty important. I might bring that up another couple times. And then also that table sort of continues, and we did see this last time also, that when we get past base 10, like 11 or higher, sometimes we actually use letters. And these letters represent like 10, 11, 12, 13, 14, 15. And that's because when we get past base 10, sometimes a number like 10 or 11 or 12, they need to be single digits, but obviously they're not single digits. So we use like a single character to represent those in certain bases. So this table is going to be helpful also. I'll probably go back and forth with this, but digits we're allowed to use in these bases, and then what those letters stand for. Going back to my screen share. Again, I don't want to do too much with this because it's going to be better to do the problems actually working them out. But I just wanted to show you these last few. If we were going to convert 53 to base 2, we would look at all the powers of 2. And once we hit something that's bigger than the number we're dealing with, we ignore that. So I'm not going to divide 53 by 64, but I'm going to start by dividing 53 by 32. I'm going to take note of how many times like 32 goes into 53, for example, and then whatever the remainder is, I'm going to divide by the next thing up. And then whatever the remainder is there, I'm going to divide by the next thing up. And you will see, you can pause this and read it a little closer if you would like. And most of you probably have access to this handout anyways. But if you want to pause this page and read it a little bit, you're welcome to. Kind of just scroll through slowly in case anyone wants to pause and read it a little further. A lot of long division is going to happen today. So the number 53 turns out to equal 110101 base 2. I think I have another couple here. Here's a converting into base 16. I'll let you read through this if you would like. And your final answer is 7C4 base 16. So 1988 turned out to equal 7C4 base 16. Okay, I think we're going to stop with the screen share here and go ahead and do the actual examples. It's going to make a lot more sense right now when we go through examples together here. So, okay, so let's go ahead and go to our first real example here. This will be convert the given base 10 number to the indicated base. So I have a couple problems on this page. So there's two questions on this page. So we're going to convert the number 97 into base 5, and we're going to convert the number 178 into base 5. The way I would approach these problems, I would start with looking at what base 5 numbers, sort of like what do they look like? Like what do the place values represent? The one on the far right represents the 5 to the zeros position. The one right next to that represents the 5 to the first powers position, and so on. Right next to that represents 5 to the second powers position, 5 to the third powers position, 5 to the fourth powers position, and of course that keeps going. Okay, I'm doing fives because it says we're converting into base 5. That's why I'm looking at powers of 5 up here. Okay. Like, remember, anything to the 0 power is 1. 5 to the first power is 5. 5 times 5 is 25. 5 times 5 times 5 is 125. And if you multiply that by 5, you get 625. And that just keeps going. Right? It keeps going on forever to the left. So in my answer, when I do convert something into base 5, whatever goes here tells me how many ones we have. That's the ones place. Whatever I put here tells me how many sets of 5s we have. Whatever we put here tells me how many sets of 25s we have, and so on. Now, what we want to do when we're doing the long division here is we start with the 97 and we say, okay, 97, it's bigger than that, it's bigger than that, it's bigger than that, but it's not quite that big. I'm not going to need this position. I'm not going to divide 97 by 125 because it's not going to work. And so my answer is not going to involve the 125's place. My answer to this first question is going to be a 3-digit answer. It's going to be a certain amount of 25's plus a certain amount of 5's plus a certain amount of 1's. So what I'm going to do is I'm going to take 97 and I'm going to divide it by 25 because that's the last number that's not bigger than that. It's the last number I'm looking at here that's not bigger than 97. So take 97 divided by 25. Let's see what happens. If you do that on your calculator, if you want to use your calculator, 97 divided by 25 is 3 point something. Ignore the decimal part, just put 3. We then multiply 3 times 25, which is 75, and we then subtract. What we're going to do with that remainder, by the way, that 3 right there, when I divide it by 25, that tells me I'm going to have a 3 in my answer right there in the 25's place. Okay? So that 3 can go right there. We take the remainder and we always divide by the next thing going to the right. So I'm going to divide by 5. I'm going to divide 22 by 5. Divide 22 by 5, it goes in 4 times. 4 times 5 is 20. We have a remainder of 2. So my 3, when I divide it by 25, my 3 is going to go in that position. When I divide it by 5, that 4 is going to go in that position. And then once you get down to that step, that last remainder always goes in the 1 spot. So that 2 is going to go over here in the 1 spot. So my final answer, I mean, we're actually ready to give the final answer. 97 turns out to equal 342 base 5. It is important that you write the base number like I just did, because you need to say what base we're switching it into. And again, just so you know where these came from, 25 went into 97 3 times. So we put a 3 in the 25 spot. So that 3 is right there. We took the remainder, we divided by the next place value over to the right, went in 4 times. So we put a 4 in the 5 position there, right there. And then finally, your last remainder, once you do that, always goes in the 1's position. The second question on this page also is doing base 5, but we're doing 178 into base 5. Notice 178 is bigger than 125. So I am going to start by dividing 178 by 125. I didn't have to use 125 in this problem because 97 isn't that big. Now notice 178 is not that big, so I'm not going to need this position. But I expect my answer here to be a 4-digit number, a 4-digit answer, because 178 does have a set of 125 in it, and probably some other of these things. So I'm going to start by dividing 178 by 125, not 625, because that's bigger than that. So 178 divide by 125. Go ahead and do it on your calculator if you would like. 178 divided by 125. Don't use any fraction bar or anything. Use the actual division sign. Should give you a decimal answer. It goes in once. Ignore the decimal part. Just take the whole number 1. 1 times 125 is 125, and then we subtract right here. We take that 53 and you always go divide it by the next thing over. So we just started by dividing by 125. The next place value over to the right, in this case, is 25. So I'm going to take the remainder and divide it by the next place value over. In other words, I'm trying to figure out how many times 25 goes into 53. If you do the long division, 25 goes in there twice. Remainder of 3. So I already know there's going to be a 1 in my 125 spot. In my final answer, there's going to be a 1 right there. I know there's going to be a 2 in the 25's position. I know there's going to be a 2 right there in my answer. 1, 2. Now what's going to go here? Well, how many sets of 5s are there? So remember, you always take your remainder and you divide by the next place value over to the right. I need to take 3 and divide it by 5. I know that looks weird, and a lot of people don't like that because 5 is bigger than 3. A lot of people just want to switch those because it looks better to them, but that's not how it goes. You always take your remainder and you divide by the next thing. And I know 5 is bigger than 3. That means when I divide 3 by 5, it doesn't go in at all. In fact, it's 0 point something. And that's okay. That simply means there's going to be a 0 right there in my answer. Some numbers have zeros in them. That's okay. So 0 times 5 is 0. Remainder of 3. That last remainder is going to go over there. Okay. So my answer is going to be 1, 2, 0, 3 base 5. In other words, 178 in a base 10, like a regular number like we're used to. If we were to convert it into base 5, would be equal to 1203 base 5. So if we lived in some alternate universe where we had used base 5 instead of base 10, the number that we think of as 178 would instead be written as 1203. Again, the 1 came from when we divided by 125. That's why there ended up being a 1 in the 125's position. The 2 came from when we divided by 25. That's why there ends up being a 2 in the 25's position. The 0 came when we divided by 5. There's a 0 in the 5's position. And finally, that last remainder always becomes your 1's position, right? So we never actually divide by 1. You don't need to divide by 1. 3 divided by 1 would still be 3 anyway, so there's no reason to divide by 1 at the end. Just take that last remainder and put it there. So 178 equals to 1203 base 5. Let's do a couple base 9 examples. Base 9. If you feel confident, maybe you might want to pause the video and try these two on your own. If you're not too confident yet, then you can keep watching. We can try it together here. What I would start with is I'm doing base 9. So let's start looking at what do powers of 9 look like. Let's look at some powers of 9. So like my far right position is going to be 9 to the 0 power position, 9 to the first power position, 9 to the second, and so on, right? And it just keeps going forever. Now let's start to see what these are equal to. Of course, 9 to the 0 is 1. 9 to the first power is 9. 9 times 9 is 81. 9 times 9 times 9 is 729. Okay. I don't really think I need to go any further at the moment, and that's because these numbers that I'm dealing with are not that big, right? I mean, 47 isn't even that big, right? 561 is bigger than 81, but it's not that big. So I'm really not going to need this place value at all. But to start looking at powers of 9, we're going to divide 47 by whichever one is the biggest, but not bigger than that. Okay, so I'm going to start this problem by dividing 47. I could divide 47 by 1, of course. I could divide 47 by 9, of course. I cannot divide 47 by 81, or like I could. It would just be a 0 in that spot. And same thing if I divided 47 by 729. So there's no reason to have leading zeros in your answer. So find the biggest number here that's not bigger than that, and then divide 47 by it. We're going to start by dividing 47 by 9. So 9 goes into 47 5 times. 5 times 9 is 45. You get a remainder of 2. We're actually finished already because 9 went into 47 5 times. That means I'm going to have a 5 in the 9's position. I'm going to have a 5 right there. And then remember, your last position is always just this way. I'm going to have a 2 right there. We're actually finished already with this problem. 47 is equal to 5, 2 in base 9 land, right? 47 equals 5, 2 base 9. In other words, let me do this. In other words, 47 equals 5 sets of 9 plus 2 sets of 1. Remember, there's a 5 here and a 2 here. So 5 sets of 9 plus 2 sets of 1. That would be 47. Think about it. 5 times 9 plus 2 times 1. 45 plus 2, right? And so we're saying 47 equals 5 sets of 9 plus 2 sets of 1, which it does. If I wanted to change 561 into base 9, I'm not going to start by dividing by 9 because I could divide 561 by 81. Like 81 is going to fit into there. There's no real reason for me to divide 561 by 729 because it wouldn't go in. Like 729 is bigger than that. So 729 would go in there 0 times. And there's no reason to have a 0 in the start of your number. Okay. So find the biggest number here that's not bigger than that and divide the 561 by that number. In this case, 561 divided by 81 is the first thing we're going to do. Okay, so go ahead and do 561 divided by 81. Use your calculator if you want. You're going to see that it's 6 point something, so it goes in 6 times. Go ahead and do 6 times 81. You're going to get 486. And then go ahead and subtract. I'm getting 75 when I do that subtraction. So we still got a little work to do, but I know that 6 is going to go in the 81's position. I know there's going to be a 6 right here in my answer. Remember, you take the remainder and you go divide by the next thing over to the right, the next place value over to the right. So we always take the 75 now and divide it by 9 in this case. 9 times 8 gets you as close as you can to 75 without going over. So I know there's going to be an 8 in the 9's position. There's going to be an 8 right here in my answer. And then that last remainder goes here. Okay, so my answer is going to be 683. 6 in the 81 spot, 8 in the 9 spot, and then 3 over here in the 1 spot. So my final answer is that 561 equals to 683 base 9. And I think these arrows are helpful also. So 6, 8, and then final remainder goes way on the far right. Could I have taken 3 and divided it by 1? Sure, if you want to, but it's really kind of pointless because it's still going to be 3. It's always divide by 1, nothing changes, right? So technically, I guess you could say you could do one more long division, but it's going to be 3 divided by 1, but it's just going to remain a 3. That's why I just say skip that part, put that right there. For the next page, let's look at a couple base 2 examples. So let's switch some things into base 2. All right, now base 2 numbers can get really long. And the reason is because when you're doing base 2, everything has to be just zeros and ones. If we either have 0 sets of something or we have 1 set of something. And so they can get really long answers when you're doing base 2. So be careful. Like base 2 seems like it should be one of the easier ones, but it's probably one of the more difficult ones because our answers are really long and ugly, and there's a lot of long division that needs to be done sometimes. So let me show you what I mean. So in base 2 on the far right would be well, it'd still be the ones position because 2 and 2 to the 0 is still 1. 2 to the first power is 2. The next position would be the 2 to the second power's position, which is the 4's position. The next place value would be the 8th position because 2 times 2 times 2. Then the 16's position. Then the 32's position. And you might say, why are you going so far? Why do you keep going? Well, I know we're not going to need all these for this one, but for 123, I mean, we haven't passed 123 yet. So let me keep going a little bit. 2 to the 6th power is 64. 2 to the 7th power is 128. Finally, I passed 123. So when I do 123, I'm not going to need this place value, but I am going to need all the other ones. It's going to be a really long answer. This one is not as bad. I could divide 3 by 1. I could divide 3 by 2. I can't divide 3 by 4 or 8 or 16 or anything. I mean, I could, but it's just going to be 0, and there's really no reason to have zeros in the front of your number. So we start by finding the biggest number here that's not bigger than that. And then we divide 3 by that number. So we're going to divide 3 by 2 first. Of course, 2 only goes into 3 one time. 1 times 2 is 2. And we have a remainder of 1. And we're actually finished already because I have a 1 in the 2's position. I'm going to put a 1 right there. Then I'm going to put a 1 over here in the 1's position. So basically 3 is equal to 1, 1 base 2. That one, when I divided by 2, went in the 2's position. That final remainder went over here. Okay, basically we're saying that 3 is equal to 1 set of 2 plus 1 set of 1. Okay, 1 set of 2 plus 1 set of 1. My next one's going to be a lot longer because there's going to be a lot of long divisions to do. Now, 123 is bigger than all these numbers, except it's not bigger than that. So I'm not going to worry about this position, but I am going to have to start by taking 123 divided by 64. Okay, I'm not going to need this 2 to the 7th position, but I am going to need all the other ones. So 123 divided by 64, what do we get when we do that? Go ahead and go through the long division. It's only going to go in once. Okay, 64 goes in there one time. 1 times 64 is 64. Then we subtract. And we get 59. So I already know there's going to be a 1 in the 64's position. My answer is going to have a 1 right here. Remember, what you do is you take your remainder and you always go divide by the next place value over to the right. So I'm going to take 59 and divide by 32. 32 goes into 59 one time. 1 times 32 is 32. Go ahead and subtract, we get 27. I know there's going to be a 1 in the 32's, but I'm going to have a 1 right here in my answer. You take the remainder and go divide by the next place value over. In this case, divide by 16. 16 goes into 27 once. 1 times 16, remainder of 11. There's going to be a 1 in the 16's position in my answer. Take that 11, divide by the next place value over. 8 goes into 11 once. 1 times 8. Get a 3. I'm going to have a 1 in my 8's position. There will be a 1 right there in my answer. Take that 3, divide by the next place value over, which is 4. We're always taking the remainder and dividing it by the next place value over. 3 divided by 4. I know that looks weird. This is where some people freak out. And they're like, wow, I can't do 3 divided by 4. It doesn't work. It doesn't go in, right? I mean, you can do it. It's just a 0, and that's okay. That just means there's going to be a 0 right there. Like your answer sometimes has zeros in it. Numbers sometimes have zeros in them. 0 times 4 is 0. Okay, so I'm going to have a 0 in the 4's position in my answer. I take that remainder and divide by the next thing. 2 goes into 3 once. 1 times 2. Remainder of 1. I'm going to have a 1 in the 2's position. And that one's going to go away over here. Okay. 123 is equal to 1111011 in base 2. 1111011 in base 2. That one is here in the 64 spot. Remember, we didn't need this spot, so the 64 went in there once, so that one is here. That one is representing the fact there was one set of 32. That one is representing the fact that there was one set of 16. That one is representing that there's one set of 8. That 0 is representing the 0 sets of 4. That one is representing the fact there was one set of 2. And that final one is representing that we had one left over. That means there was one set of 1 left over at the end. So that's a lot. Like a lot of, again, a lot of people think base 2, oh, that should be easy. 2 is so little and easy. But for many people, base 2 is one of the hardest to do because it's so long sometimes. Let's move on and try base 16. Okay, so let's talk about maybe changing a couple numbers into base 16. So let's start looking at powers of 16. What do some different powers of 16 maybe look like? 16 to the 0 power. We got 16 to the 1st power. We got 16 squared. We got 16 to the 3rd power, which is 16 times 16 times 16, which is 4,096. Now, of course, I could keep going. I could do 16 to the 4th, 16 to the 5th, 16 to the 6th, but I'm already at a number that's bigger than what I need to deal with. I'm only dealing with, 133 and 1,241. I'm already at a number that's bigger than both of those. Okay, so I'm not going to need to go this far. In fact, for the 133, I don't even need this position, right? For the 133, I'm going to have a certain amount of 16s plus a certain amount of 1s. My answer to this first question is just going to be a 2-digit number because I'm only going to need these place values because that number is bigger than what I'm dealing with. So I know my answer here is going to be a 2-digit number. So I'm going to start by dividing 133 by 16. Okay. Divide this by the biggest thing you can that's not bigger than that. So I can divide by 1, I could divide by 16. I don't really want to divide by 256 because it's just going to put a 0 right there. 'No reason to divide by 4,096. It's just going to put a 0 right there. 'No reason to divide by 4,096. It's just going to put a 0 right there. 'No reason to divide by 256 because it's just going to put a 0 right there. 'No reason to divide by 4,096. It's just going to put a 0 right there. 'No reason to divide by 4,096. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to divide by 4,096. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to divide by 256. It's just going to put a 0 right there. 'No reason to div We don't, it's okay for zeros to show up within your number, but we don't want there to be a zero like in the beginning. Like we don't want leading zeros. It just is weird, right? What do I mean by we don't want leading zeros? I mean, for example, what if your answer to a question was like 35? I'm just making this up. What if that was your answer to a math question? And then what if someone else wrote it like this? You just had like a leading zero right there. Well, you'd be like, well, why did you put that zero there? It's not necessary. That's just 35. Sometimes it makes me think, why put leading zeros in a number? Those don't do anything for us, right? Not necessary. So that's what I mean when I say we don't want leading zeros, but it's okay to have a zero in the middle of your number. That happens sometimes. Okay. So anyways, I'm going to start by taking 133 and dividing it by 16. Okay, so 133 divided by 16, it goes in there 8 times. And then go ahead and do 8 times 16. You're going to get 128. And go ahead and subtract. You will get that. So we're actually finished with this problem already because 133 is 8 sets of 16 plus an extra 5 left over. There's going to be an 8 in the 16 spot, and there's going to be 5 left over, 5 sets of 1. And so 133 is equal to 8, 5 base 16 is what we're saying. 133 equals 8 sets of 16 plus 5 sets of 1. I know I've been saying that. I haven't really been writing it out. You don't need to write it out, but if you kind of wanted to check, 133 should be equal to 8 times 16 plus 5 times 1. 8 times 16 is 128. 5 times 1 is 5. This is just saying 133 equals to 128 plus 5, which of course it does. I mean, you can kind of see it right here. 8 times 16 is 128. We had 5 left over. 128 plus 5. Okay. But my final answer is this right here. If I'm changing 1,241 into base 16, think about what you're going to divide it by. Sure, you could divide it by 1. Of course, you could divide it by 16. We could even divide it by 256. I don't want to divide it by 4,096 because then that would just be 0. I don't want leading zeros. So find the biggest number that's not bigger than the number you're dealing with. Find the biggest number here, but not something bigger than that. And divide. So divide 1241 by 256. You should find that it goes in 4 times. It's 4 point something, but ignore the decimal part. Go ahead and do 4 times 256 to get 1,024, and go ahead and subtract. I'm getting 217. Okay, so I know in my answer we're going to put a 4 in the 256 position. I already know I'm going to have a 4 right here in my answer. But the next thing is to take your remainder and divide by the next place value over. So now I want to know how many times does 16 fit into 217. In other words, I want to take 217 and divide by 16. So go ahead and do it on your calculator. 217 divided by 16. You'll notice that it's 13 point something. Okay. Go ahead and take 13 times 16. You get 208. And then we subtract, we get 9. I'm going to have a 13 in the 16's position. In other words, I'm going to have a 13 right here. Now you say, wait, how can I put 13 right there? 13's a 2-digit number, but there's only one spot. So how do I put 13 right there? Well, that's where this comes into play. Remember, in base 16, which is what we're dealing with right now, 13 actually is a single digit number. Okay, these are all single digit numbers. 0 through 9, and then this represents 10, 11, 12, 13, 14, 15. So 13 is a single digit number. We just don't write it as 13, we write it as D. So when I go to basically put 13 right there, I'm actually going to put the letter D right there. So that's where this comes into play. 10, 11, 12, 13, 14, 15. Those are all single digit numbers when we're talking about base 16. So we have to use single digit characters. So we just basically say, well, let's use letters because we kind of, 13 really isn't a single digit number in base 10, but it's supposed to be in base 16. So we start using letters. So my answer is going to be that 1241 equals 4B9 when we switch it to base 16. I didn't say 49, like 49, 4D9. That's the letter D right there. Oh, that looks weird, right? That's a letter showing up in our numbers, but there's a 4 in the 256 position. I never did the arrows up here, did I? I'm not gonna be able to sleep tonight if I don't do that. There's a 4 in the 256 position. There's a 13 in the 16th position, but we don't write it as 13. We write it as D. And then there's a 9 in the 1st position right there. In other words, 1,241 equals 4 sets of 256 plus 13 sets of 16 plus 9 sets of 1. What we're saying there is that 1,241 equals 4 sets of 256 plus 13 sets of 16 plus 9 sets of 1. If you go through the math on this, that should turn out to be 1,241. You're going to get 1,024. You're going to get 208. You're going to get 9. If you add those numbers all up, it should add up to that. But the final answer is 4D9 base 16. That's my actual answer right there. Let's do another base 16 problem. And this one's going to be kind of long and ugly. Good time to pause the video if you want. So I've reserved the whole page for this one. Pause the video if you want and try this problem. It's a good challenging problem. We have 16 to the zeros position. We have the 16 to the first powers position, 16 to the second powers position. Now 4,096 is already pretty big, but it's not that big. So I'm going to keep trying. I want to keep going until I hit something bigger than the number I'm dealing with. Now I just did 65,536. Okay, so I'm not going to need this place value because 65,536 is bigger than the number we're dealing with, but I do need these other place values. I'm going to start by dividing the 32,000 number by 4,096. So I'm going to have a 1, 2, 3, 4 digit answer. because I don't need this place value here. That's too big. That's bigger than that. So find the biggest number here that's not bigger than that, which is 4,096, and we'll do the long division there. So 32,267 divided by 4,096. Go ahead and start with that and see what happens. It's a big ugly number, but it's 7 point something. So just take the 7 times 4,096 goes here, 28,672, and subtract. 3,595. Okay, let's just pause for a second. So that 7, the fact that 4,096 went in there 7 times means I'm going to have a 7 in the 4,096 position. My final answer will have a 7 right there in that position. Then I take the remainder and always go divide by the next one over to the right. So I'm going to take that divided by that. I'm going to take 3,595 divide by 256. It goes in 14 times. 14 times 256 is 3,584. And then we subtract there and we get 11. Okay. So I know that I'm going to have a 14 in the 256 position. I know I'm going to have a 14 right here. Again, how can I put a 14 there? There's only one space. How can I put a double-digit number? Well, we're not going to actually put 14. We're going to put the letter E. Okay, we're dealing with base 16. So this means 9, 10, 11, 12, 13, 14, 15. So that's 14 right there. So when I go to put my 14 in my answer, I'm actually going to write it as the letter E. Always take the remainder that you get right there and divide by the next place value over. So I need to take 11 divided by 16. I realize 11 doesn't go into 16. I realize 16 doesn't go into 11. That is okay. That just means we're going to have a 0 right there. 0 times 16 is 0. Subtract and get 11. And then I'm going to have an 11 in that spot. Okay. 0 sets of 16. I'm going to have a 0 in the 16 spot. I'm going to have an 11 right there. Same thing, we're not actually going to write 11 because we can't put a double-digit thing in a single place, but 11 is the same as B. So a 7 goes in that spot, 14 goes in that spot, a 0 goes in that spot, and 11 goes in that spot. So my final answer is going to be that 32,267 is equal to 7, and then 14, which is actually E, and then 0, that is a 0 right there. That's not the letter O, that's a 0. And then 11 goes here, but 11 is actually B. 16, so let me squeeze the word 16 there, because that's necessary. Told you that was a tough one. Okay. This is a 0, that is not the letter O, that's a 0. You know, they look very similar. Those are letters, the E and the B, but that's not a letter, that's a number. And so a 7 went in the 4,096 position. A 14 or an E actually went in the 256 position. A 0 went in the 16s position. And finally, an 11 went in the ones position, but we actually wrote it as B instead of 11. So that's my final answer right there. 32,267 equals 7E0B base 16. That is the number 0 right there. You don't have to do this last thing that I've been doing, but what we're saying is we mean when we write this is that 32,267 equals 7 sets of 4,096 plus 14 sets of 256 plus 0 sets of 16 plus 11 sets of 1. That's what we're saying when we write this right here. 7 times 4,096. When we just did it over here, it's 28,672. I'm sorry. Yes, 28,672. 14 times 256, we actually just did that right here. That's 3,584. Of course, zeros times 16 and 11 times 1. But if you add those numbers up, you get 32,267. Just like in base 10 land, we mean, when I write 32,267, I mean that there's 3 sets of 10,000, there's 2 sets of 1,000, there's 2 sets of 100, there's 6 sets of 10, and there's 7 sets of 1. That's what we mean when we're writing this in base 10. But when we write this in base 16, we mean this. They're equal to each other. They represent the same value. For the last page, I went ahead, I'm not going to go through these examples, but I want you to try these on your own for this last page. I would like you to pause the video right now and go try these 3 problems. There's a base 3 problem, a base 6 problem, and a base 14 problem. I'd like you to pause the video, try these 3 problems, come back, and I'll write the answers down, and then we'll wrap it up at that point. Okay, so again, I'm not going to go through these. I'm just going to tell you what the answer should be, and you can kind of see how you did. If you convert the number 25 into base 3, it is equal to 221 base 3. If you convert the number 724 into base 6, it turns out to be 3204 base 6. And then finally, if you convert, it's a tough one, 221,849 into base 14, you're going to have a lot of letters in this one. I purposely finished with a difficult one. It is equal to 5 A, B, C, 5 base 14. Remembering that A, B, C actually stand for these numbers here. Okay, that is it for this section. Thank you for watching.